Hey there, team, and welcome to an update on the ongoing eruption, the newest eruption in Iceland on the Reykjanes Peninsula. I'm Geology Professor Shawn Willsey. Thanks for joining me. Today is Wednesday, July 16th, and this eruption began early in the morning, Iceland time, about 3:54 a.m. Ironically, I was doing a live stream literally hours before with Johan. We were flying over the area well before the eruption began, looking at that landscape, and literally a few hours after that live stream ended, we had a new eruption, and so we rallied and got another live stream going. Johan did a couple of flights with us, which was really great. And so let's recap what we know so far, and I'll show you some images and videos of what's been going on over the past little while. So this was the 9th eruption in this area. Remember, we had our first eruption in this region on December 18th, 2023. If you go back to 2021 and the Fagradalsfjall eruptions, I guess this would be the 12th since that time. This eruption was preceded by earthquakes. So beginning in the wee hours of the night, we did have earthquakes that were occurring, fairly low magnitude, mainly under magnitude 2, but nonetheless numerous earthquakes sort of over that Sunnukur crater area, the area that's been responsible for so many of these other eruptions. And those earthquakes lasted over a few hours. And what it looked like was that there was an intrusion. So some of the magma had moved from the storage zone and had formed an intrusion in the subsurface. It was about 6.5 kilometers long, as estimated, modeled by the Met Office. As I was tracking this while the earthquakes were happening and time kind of went on and an eruption wasn't happening, those earthquakes were pretty deep initially, and so it looked for quite a while, at least to me and I'm sure others, like it was probably just going to be an intrusion. It didn't look like this was going to make it to the surface, but things accelerated pretty quickly. It actually became an eruption at, again, about 3:54 a.m. Luckily, with the earthquake precursor signs, they were able to evacuate the town of Grindavik, the Blue Lagoon, the campsite in Grindavik. Everyone was evacuated, and based on the location of this eruption, there's no threat to infrastructure at this time. So it's in a great place for this eruption to happen. It's not threatening any roadways, not threatening any towns, pipelines, or anything like that. Right now, though, I should point out the area is closed. It's still a very hazardous area, especially with the winds and the gases that are coming out of this. The gas concentrations are still pretty high, so please don't try to access this area. Let me go ahead and show you exactly where this started. And you can actually see it on the Afar TV webcam. If you look out over this area here, right about there, so this is going back to yesterday evening, well, morning, I suppose, 3:53 in the morning. This is where you're going to see the activity begin. Here's the older crater row here. That's just some of the steam coming out of those older craters. But this is where the new vent is going to open up. And you'll see, if you look closely, you'll see some of the gases coming out first. Go ahead and play that. And then you'll see the lava take over. So watch this area here where I'm pointing to. You can see it's increasing in terms of gases. Those dense gases are coming out and just forming a blanket on the ground. And then that will escalate into lava actually making its way to the surface. Looks like we're getting a little bit of an orange glow there. So there's the initiation of the eruption. And then that kind of spreads out over time. So that first vent, that first fissure was about 1 kilometer in length over time. And this is an area, I'll show you a map here in a second. This is an area sort of to the east of Stora Stokfelt. So it's much further north of Grindavik than some of the other eruptions. So there's the eruption getting started. If we kind of skip forward a little bit, kind of see it getting going. But it didn't really rip open the way we've seen some of the other eruptions in terms of the fissure rapidly lengthening to, you know, several kilometers in length. This one started out pretty small, and we'll have to see what the numbers are in terms of the total amount of magma or lava that was erupted. This was Johan's earlier flight once it was kind of going here. So you can see a nice view here of the fissure, that initial fissure, and those lava flows spreading out to the east and west. We're looking more or less to the northeast there, kind of panning around. So we're looking along the trend of the fissure, that northeast trend of the fissure, and great lighting right there. You can see those lava flows kind of spilling out in either direction there to the east and to the west. Again, this was a bit of a surprising eruption because our model estimates were that the magma storage zone was only maybe 2/3 full. We didn't think we were quite to the magma volume necessary for an eruption to take place, even though some of our GPS measurements were indicative of, being at the threshold that we previously needed for some of those eruptions to take place. Yeah, so this is where the earthquakes were concentrated during that time, and this is where the eruption began. If you go to any webcams right now, you'll be sorely disappointed because with the gases and just the weather, it's kind of socked in. You might be able to scroll back to periods of time when you can see a little bit. There's like a faint little glow there. So there are webcams that are fixed on the eruption site, but they're just too far away and the weather's lousy with the gases and such to really actually see anything. So let's go ahead and look at the Met Office update. And so, yeah, we did have fissures later by about noon or so today. Those fissures had lengthened a little bit to about 2.5 kilometers in length. But the eruption does seem to be winding down, and I'll show you some footage that shows that here in a minute. So this is our latest update that just came out within the last hour or so from the Met Office. So the eruption has lengthened, okay, but the lava flow continues, but is slowed. So so even though we had the fissure lengthen for a bit, the actual amount of lava coming out has slowed down quite a bit. Most of the lava is coming out on that east side. The seismic activity is almost down to zero, so the earthquakes have dropped off significantly. Again, that's typical of what we see. Earthquake activity ramps up as the magma is making its way towards the surface, breaking rock as it goes. Once that conduit's open and the magma is coming out to the surface, then the earthquakes drop down quite a bit. But there is, yeah, there's a moss burning, so we're getting smoke from that. We're getting the gas emissions and just some of the cloudy weather there in the area, and so it's not good visibility conditions there. This is just a graph showing sort of the seismicity over time. You can see it spiking there when the eruption took place and then kind of dropping off there quickly. The map they have for us here, and that map for you, I don't think they can't click on it, so it's a little grainy, so I apologize, but I'll try to make it a little bit bigger. So just to orient you quickly, here's Grindavik down here, the power plant, the Blue Lagoon right here, and then this is the current map for the flow field. So the purple there is the lava. You can see most of it again going out to the east. The red staggered lines here showing the vents, so you can see the complete length of the vents there. So not a lot of the lava is actually moving to the north towards the roadway. That's great. Not much of it is moving to the west towards this roadway here. So that's good news. So this is a great place for this lava to sort of spill out and accumulate as we go forward with time. Let's see what else. Yeah, and then there's again the gases. Here's like a satellite view. You can see the gas plume coming off the Reykjanes Peninsula, mainly moving more or less to the north, but then it takes a westward turn there. So it has impacted a bit of folks on the Keflavik region and the Snæfellsnes Peninsula, this peninsula that sticks out here, but that SO2 plume kind of shows up there. And then because of those gases, they have changed the hazard map here a little bit. So you can see the primary hazard over here is things associated with the eruption and the lava, tephra, things like that. But then this yellow area here, this is mostly for gases and the gas pollution risk in that area. Okay, so we have those things there, and we have a great image here from Horður Kristofsson, who shared this, and so I'll make sure I put a link in the video description if you want to take a look at this. But this was from, yeah, yesterday, about 7:59 Greenwich time, and so this nicely shows, you can kind of see the whole area. So here is looking more or less to the north here, Stora Stokfelt here, pull around the Blue Lagoon, Svartsengi over here, all the different hills. Grindavik's way down there in the distance. Now we're looking more or less to the south, different landmarks there. Then as we pull over here back to the east, Again, Johan and I had flown his drone from just somewhere over here along these foothills, so we were actually quite close to where this eruption actually took place. So there's that view again of the fissure. So nice work there, and a really nice 360 image. Earthquakes, as I mentioned, have like gone to basically zero, but to give you an idea of what those were looking like earlier, so if we put the 24-hour plot in and capture all those earthquakes that happened during the lead up to the eruption, you can see all the locations of those quakes, all the magnitudes. I think the biggest one in there might be that 2.6. So there's a couple of 2s in there, and weed out anything over 2. Yeah, so a handful of 2s. And this is mainly where the eruption took place, was in this region right here. This is where the fissures opened up. So it makes sense that that's where the largest quakes were. But regionally, there was quite a few quakes along the whole length of the dike, or the Sunukur crater system here, from just north of Grindavik all the way up here to southeast of Vogar. So there was the earthquakes 24 hours ago. If we look at just earthquakes in the last, let's say, 4 hours, it's pretty quiet. So the seismicity has dropped off considerably. On the GPS front, the 4-hour plots are showing the drop down. So there's the inflation. This is the Svartsengi station. Red dots over May, June, and going into July, kind of increasing. And then you can see them drop. Those last 2 points drop. Similarly, the north, south, and the east-west plots, there's movement to the south and movement to the west there. So basically, it's been inflating, but then the eruption happens, magma moves to the surface, it leaves the subsurface, and so there's a deflationary response, and we're seeing that with the GPS data. The last thing I want to leave you with here quickly with this update is some really great footage this morning from our good friend Isak, who has a YouTube channel as well as his drone that he flies over the eruption sites and other places. He does great work, so I encourage you to check out his YouTube page, Isak Finnbogason. I probably butchered that, but that's his site down there in the bottom left corner. And so I just want to show you a few things from his very long flights this morning or earlier today. He did several flights, I think maybe 5, 6, maybe more. I think they might even still be going on. If he's still streaming right now as I post this update, I'd encourage you to go over to his site first and kind of check out what he's doing, and then you can come back and catch me anytime. But who knows how long he'll go on with that streaming there. But what's most interesting here is he flew out to the eruption site, and you can see over time that the eruption's kind of dying down a little bit in terms of just lava output. But the most interesting thing is he flew back for a battery change, and then as he came back out to the area, we had this zone right here that was erupting a little more vigorously. So you can see it's not just lava like this fissure on the right here, but we're getting a little bit more vigorous activity, clots of lava, busted up pieces of crust being thrown out. And so this is indicative of some water mixing in with the lava. Groundwater is mixing in with some of that lava, and there's enough water, or the lava supply is low enough that the water makes a difference in, as it flashes into steam and becomes larger by volume, that provides a much more explosive force that pushes the material out. But notice there's still lava here. So let's keep an eye on this fissure, because we're going to see this a couple times. But this was sort of the start of this behavior as this fissure with lava transitioned into a bit more of what I would call a phreatomagmatic eruption. A phreatomagmatic eruption is where magma and water are mixing. And the real behavior that you see here depends somewhat on the ratios. If there's an overwhelming amount of lava, then it sort of seals off the groundwater, and the groundwater can't really mix or cause any change in the eruption. But if the lava supply wanes, or if you increase the groundwater supply a little bit, which is harder to do, but usually it's the lava supply waning, more mixing there, and then you get something a little bit different. So that's how it was initially. Then he went in for another battery swap, and then when he flew back out, that same area, so there's that same area we looked at, had changed its behavior considerably. So now if you check it out, you'll see that it has no lava for the most part associated with it, a little patch over here, but now it is more effectively just more of a phreatic eruption, more of a steam-driven eruption. You can see it's not just blasting out steam, but rocks are coming out, and you can see some of those kind of trailing off there with little kind of streamers attached to them, almost little steam plumes kind of following behind them. You can also, if you look at the white plume, you can see some of these dark rocks being thrown out in front of it. So this is incredibly vigorous activity. This is what we would call maybe like phreatomagmatic jetting. And this is real time. This is at real speed. So I know that looks like super fast, but that's actually the actual speed of that eruptive behavior going. So it's actually throwing out large clots. It's behaving a little bit more explosively. Again, this is very localized. So this is what was happening during this quick flight by ESAC. And then he went in for another battery. So there's a nice view of it there. And it's sort of at the leading edge of this rift here, this fissure system. These fissures seem to be, have a good supply of lava in them, and so they're continuing to erupt lava. But this one, I think the lava supply just got so small that the groundwater was mixing with it, and the behavior changed pretty incredibly. And so then he goes in for another battery swap, and then flies back out. And now the same location had changed a little bit. So now instead of that white water vapor or steam-rich plume, now we had one that looked the same, but these darker ones here. And these darker ones might be where there's a little bit more lava or less water mixing in with it. So we've increased think of the ratios here as a balance, more lava supply. So it's actually blasting out a bit of ash. So it's actually blowing out pieces of lava explosively into tiny, tiny shards, and that's what we would call ash there. So you can see the color of the plume a little bit tells us about what's going on, where it's mostly steam driven, but also still throwing out rocks every now and then, versus more fine particles of shredded lava here with these darker plumes. So really great work by ESAC, and I think he had fun along with everyone else that was watching. This was front row seat into some really cool volcanic behavior here. I mean, it looks sped up, but that's the real speed of which these are occurring. You can see these chunks of lava just being thrown out. It's kind of tearing up and reaming out that vent. So this vent's probably becoming wider as the force of these phreatic or steam-driven explosions are ripping up clots of lava, ripping up the wall rock around the vent, and again, reaming or widening out that vent area. So we had this flight here with the dark plume. Then he went in for another battery change. It was fun because it was just changing each time he got his drone back out there. Things had changed just a little bit. So it was happening just over a few minutes. And now you can see it's mostly these darker plumes here coming out, and a little bit more of the lava over here. So again, just really interesting behavior, and just we got to see several different sort of phases of not just an eruption, but a phreatomagmatic eruption. And again, these proportions of lava versus water making changes in the eruption dynamics. So that was one there. And then I think the last one I'll show you, there's a nice view there of, you've got, again, steam driven, more ash rich eruptions here, and lava. So I mean, that's just a beautiful shot showing three different types of behavior, all from the same eruption. Then went in for another battery change, and then I think the last one I saw here, things had kind of started to quiet down a little bit. So it mainly just transferred over to the steam or water vapor driven eruptions without those dark plumes. And you can see it's not pulsing and jetting as vigorously and energetically as it was previously. So great work by ESAC. Want to thank him for allowing me to show these short clips to you and provide some explanation to everyone. But I encourage you to watch his streams when he is up filming over this part of Iceland. So thanks so much to him for letting me do that. So yeah, the eruption does seem to be waning as we look at it. And so moving forward, we'll have to see what happens. Just a quick scheduling note as I wrap up this update. I'm actually leaving this afternoon to go on a family camping and rafting trip. I'll be gone through the weekend till Sunday. I'll be able to check messages and stuff, but not able to put together another update. So I will try to circle back early next week, and we'll see what changes have taken place here. But based on what I'm seeing here, there's a pretty good chance that this eruption will kind of die down. Could be today, could be another day or so, and kind of end here within the next few days. But thanks for your support of the channel. Thanks for joining me. Hope you've enjoyed learning along with me. Great eruption in terms of just fascinating and just lots to learn as we study the Earth together. And luckily enough, just no damage at all and no impact on the people of Iceland. So thanks so much. Take care and be well.